Hello viewers and welcome to a new STM32 World video. In this video we are going to talk about STM32 Watchdogs. And I do say watchdogs because it actually does have two different watchdogs built in, but we are going to focus on one of them today. Now, what is a watchdog? In terms of embedded electronics, a watchdog is a device that actually monitors that the other devices are behaving in the way they are supposed to behave, and in case they don't, do something in a response to that. The STM32 got two different watchdogs. It's got something called the Independent Watchdog and something called the Window Watchdog. The Independent Watchdog is running completely separate from the core and the core buses and everything. The Window Watchdog is a more integrated part of the circuit, and that one requires a specially timed reset or refresh. Today we are only going to look at the Independent Watchdog. So schematically, the Independent Watchdog can be seen as shown in this block schematics. It's got a clock, and in the case of the watchdog, it is actually an independent clock. And once it receives a clock, it will start counting down, and when it reaches 0, it will reset the microcontroller. The microcontroller the application running in the microcontroller can prevent that reset by periodically giving it a kick or a reset. And if it receives that reset, the watchdog typer will start all over again and start counting down. So the idea is that in your application, you will reset or refresh the watchdog at fixed intervals, and then everything. If the application dies or hangs for whatever reason, that reset will not happen, and the microcontroller itself will be reset. It is interesting to see down here that the independent watchdog is actually clocked from a RC oscillator, low speed internal RC oscillator, and even if you flip to an input crystal, it will still be clocked by that 32 kilohertz internal RC oscillator. So also, let's look at a formula to calculate. Essentially, you have a prescaler that can be 4, 8, 16, 32, 64, 128, or 256. And then you have a counter which starts at 4096. It's a 12-bit counter and counting down to 0, and it will reset when it reaches 0. Following this formula, we can calculate the necessary numbers. Let's say we want a watchdog time of let's say 1.5 seconds. So we take 1.5 seconds there, we multiply by the frequency, we divide by the prescaler, and we end up with a counter of 3000. That means every 1.5 seconds we need to reset this watchdog, or refresh the watchdog, kick the watchdog, whatever you want to call it, or it will reset. So without further ado, let's actually look at the code. As usual, we have created a small project here where everything is configured and it can print out, and we have configured it to print out a tick every second. This is pretty much the same as we do every time. So there we go, we have a tick, and it prints how many times it cycles around the loop. I'm going to add a feature here, and I am not going to take credit for this. This is something I found on the internet somewhere, but it is listed on this page, and it's basically, when the STM32 starts up, it is possible to show the reason for the last reset. And I'm going to add this code. I lifted it off a post somewhere on the internet. It is listed on the wiki page where I found it. So let's just add this here. But needless to say, it just looks up a register or multiple, looking at multiple registers to find a reset course, and then it actually have a list of those reset courses, and it can make a string that describe that reset course. So let's try to put that into our code at the startup. Wait, I'm copying from. So down here, after we printed starting, we can print we can get the reset course, and we can print the text of that reset course. Let's try to do that. There. So it was a software reset, which is correct since we were flashing it. Just for fun, let me try to actually press the reset button on the board, and it will come out as an external reset pin reset. So hopefully, if our watchdog is enabled, we will get the explanation there. So let's go into STM32 Cube MX. Oops, wait, I need to save this before I generate that. So up here under the system core, we have the Independent Watchdog. We also have the window watchdog, but let's not bother with that for now. All we need to do is activate it, and down here we can set the values we discussed. We can set this P to 16, the prescaler to 16, and then we choose 3000. That should give us a 1.5 second window to get this activated. Let's generate the code. There we go. And let's try to run this code. Now, if this runs as expected, it will just keep resetting, because there we go, Independent Watchdog reset. So after it have time to print out the first tick, because it's running 1.5 second. So it'll print out the first tick, and then it'll reset, and it'll just keep resetting, because we never refresh the watchdog. So let's add the watchdog refresh. So let's go down here in our main loop, and let's add a little extra stuff down there. First of all, I want to add a reset interval. This could also be a define, probably be more logical, but in this case, let's do next IWDG equals 0. We want to refresh the watchdog immediately so that we don't miss the first one, and then we can simply do it down in our loop exactly like we would do if we were blinking a LED or whatever we're doing. We can do it here. So if the next IV plus that refresh interval, and the way you reset it is simply to call hell IWDG refresh with the handler of that watchdog. And let's try to run this now. So now you can see, because we refresh the watchdog, the system is not resetting. Now, I said I put this at 1.5 second, the refresh time, but as you can see at the moment, we're actually resetting this every second. What happened if we actually did it at 1500 milliseconds? And you will see that that doesn't necessarily work. It doesn't work. We can try to set it at 1490. I think I experimentally found out was an interesting value. See how that runs? See, it actually runs now at 1490, but unless I'm mistaken, there we had a reset. So it is borderlining. It resets sometime and sometimes it does not. Now, what the hell is happening here? In order to understand that, let's look at the clock configuration of the STM32. Now, we are running the main loop from our core frequency, which is controlled by an external crystal, which is very precise, but we are running the internal watchdog from an internal RC oscillator, which is very imprecise. That means that one can be off by, I think it's about 5 or 10% it can be off. So we don't know exactly how quick that one is running. It's in the neighborhood, but it's not necessarily precise. So we need to leave ourselves some space between the refresh or the kick and the actual reset. So going for 1.5 seconds and putting our reset or refresh interval at 1000, that seems to work beautifully. It's not 50% off that oscillator. So here we go, software reset, and now it'll run forever. So the point here is that this works, but let's do one more experiment and say, okay, how do we do this? We do okay, we can do it down here. We can say in our tick loop, if now divided by 1000 is greater than, say, 10. If we go to the loop 10 times, we call the error handler. As you may remember, the error handler essentially stops everything. It's down here somewhere. It'll disable the IRQ and it'll just hang there and nothing will happen. Now let's try to run this. So now our application is running for 10 seconds and then it goes into the error handler. Let's look at the output. There. Software reset. 4, 5, 6, 7, 8, 9, 10. Now it goes into the error handler. There, watchdog. So it went in. I said greater than, right? Not greater than and equal. Where are we here? Yeah, I said greater than. If we say greater than and equal, it should only go to 10. Right. So run 10 loops, and then it will go into the error handler and nothing more will happen. And after another second, the watchdog will reset the MCU. So that's pretty much it. That's what I plan to say today, and walkthrough of the watchdog one of the watchdogs in STM32. As usual, if you feel that you learned anything from this video, please like and subscribe down below, and I love receiving comments, so please comment as well. I read all the comments and I will respond to the comments as we go along. So that's about it. Enjoy the rest of the day.